Okay, so let's actually start the next topic, which is actually linear regression, right? So we have learned in machine learning classes that what is a linear regression. Linear regression is actually nothing but mapping of say x and y in the layman terms, right? So it's actually just fitting up a particular line among the data points so that the differences between the distance of the points and their projection over the line is minimal, right? It is what the linear regression is. There are multiple algorithms through which we can train the model of linear regression, like gradient descent, and also I believe there are one single linear equations through derivation, which also gives the value of say m and c. So the line equation is y is equal to mx plus c. So we need to calculate the values m and c so that we can draw the particular line, and we find the value of these hyperparameters, or say I may say parameters. So here in this particular problem we have x is the independent variable and y is the dependent variable, so that we have these pairs, that is x1 y1 x2 y2 x and yn are the observations. Then we have the y is equal to a plus bx, that is b is actually your slope, x is your data point, and a is the particular coefficient or the constant. Then different values of a and b will give different lines, right? Means we will try to change different and different values and we'll get different lines. So y, whatever we actually calculate from a plus bx, we will actually get an approximated y value. And now it means that the actual y bar is actually your approximated value, and y is your actual value, right? So it means that y is equals to a plus bx, which is the approximate value, plus some error. Means there is some error between this, and that's actually being compensated by this particular term. The error is actually given by y minus a minus bx, because only the error term is actually left there, and we are actually given with y minus a minus bx. And for the similar fashion with all the data points, right, from 1 to say n, we will actually do yi minus a minus bxi. A and b are actually constant parameters which are learned from the line, and xi is actually your point. So now we can minimize the squared residuals. Now what is this squared residuals? Whatever this particular term is, that we can actually square this thing, that's actually an error, whether in negative or positive. That's why we actually do the square of it, and we'll actually just add all of those, and also before adding we'll actually find the derivative of those, right? Something like that, because this actually how you will actually find the differentiation. Now okay, so firstly let's actually talk of the error. The error is actually just the squares and summation over all of the data points, right, of this particular error term. And then how will you actually optimize the value of a and b? You will actually just derivate it, this particular cost function, with respect to a. Then you will actually get the update term, which will be actually added or say subtracted according to the sign of this particular derivative from the particular value, right? Generally it's actually subtracted so that you can actually go down the slope, because the derivative actually gives you the value towards the slope, towards upway of the slope, and you want to go downwards because you want to minimize the cost. Hey, the second one is that you actually want to optimize the value of b. That's why you will actually do this particular derivative, and with the derivation with respect to b. Now differentiating it, we get after differentiating this particular term, right, we actually get what? We get a cap is equals to minus y minus b cap and then x, right? So what is this b cap? B cap is nothing but this particular term, right? And that's actually your say covariance about below variance, right? This is the whole differentiation behind it. We are actually not focused about the derivation, but the end product is that we actually get the b in such a way that sum over all of the particular training samples, and then multiply the xi minus x bar. X bar is nothing but the mean of all the values, and then we'll actually subtract the each x entry from its mean. And then we also multiply with the yi minus y bar, and the y is actually the mean of the y values, and then it will be divided by x, all x value, and we subtract x bar, that is mean of x, from the x values, and we'll actually do the square of all those terms, and then we'll add up. In the numerator we have xi minus x bar multiplied by yi minus y bar, sum over all. In the denominator we have xi minus x bars whole square and sum over all. So this is nothing other than but the covariance of x and y divided by variance of x, right? Because this is actually the variance term. The divide by n term is actually being cancelled from here to here, right? That's why it's actually not visible and actually get cancelled up, right? So now correlation coefficient is equals to, you are actually doing what? Another term is that there is a correlation coefficient. So correlation coefficient comes out to be b cap multiplied by summation over 1 to n and xi minus x bars whole square divided by summation over 1 to n xi yi minus y bars whole square. Now we have the r equals to 0, then it means no relation, that is independency. R is actually positive, means positively related, and r is actually negative, means negatively related. So this is a particular R metric, right? That's actually your correlation coefficient. You want to say that whether x and y are related, or whether they are positively related, or whether they are negatively related, or they are not related at all. So to actually get that coefficient matrix, you will first calculate this b by using this covariance by variance, and then you will multiply that with this particular term, that is on the numerator you will have summation over 1 to n and xi minus x bars whole square divided by summation over 1 to n yi minus y bars whole square, right? And then this R metric will give you a value of say 0 for no relation, no correlation at all in between the variables. It will give you a value of say positive value. It will signify how much the values are positively correlated, and a negative value for saying that the values are negatively correlated. So let's understand with an example that watching TV reduces the amount of physical exercise, right? Means okay, and the case increasing weight gain, a sample of 15 10-year-old children was taken, right? Means basically 15 children were taken as a sample, and there is a study that says that if you watch TV you will actually lose a physical exercise whatever you do, and it will create the weight gain on your belly. Then the number of pounds each child was overweight was recorded, means how much there is an increase in the weight. It is actually recorded from the children from the 15 samples. A negative number indicates the child is underweight, and if even if the weight is actually gone or decreased, then there is a negative weight recorded, otherwise positive weight is recorded. Additionally, the number of hours of TV view per weeks were also recorded, means how many hours does a child actually watch TV is also recorded. Find out the regression line and describe what the coefficient tells you about the relationship between the two variables. Means you need to find out the particular regression line, and you need to tell that how much you are watching TV and how much the weight is actually getting increased. That's what the you are actually supposed to tell. Now, okay, so this is your particular thing, right? Okay, so you are actually asked to find the correlation metric, right? Correlation metric. So okay, so correlation coefficient is actually calculated as this. We already know this, and how to actually calculate that. I believe that from this particular B metric, right, this term will actually get cancelled up with this numerator, right? And only thing left in the denominator will be this y cap, right? Because yes, on the numerator will be have this, and on the denominator we will have this y thing, because this x thing will actually get cancelled up with this, because this is in multiplication with that. Okay, so regression on the table format, after we need to calculate the correlation only. So what we are supposed to do is that we need to make a table, right, like this, right? And then we have the TV, and then we have the every weight, right? Means what are the weights or the increasement or decreasement in the weight. So we actually calculate the x bar, that's actually our mean of x. So that's coming out to be say this month, that is 31.6, and we also calculated the y bar, that's actually 86 by 15, that's actually 5.733. So the means are also calculated. Now we calculated what is actually, we need xi minus x bar, right? That's why whatever the mean was, we will actually calculate that from that. Similarly, we will also calculate yi minus y bar, and for all of the values we will calculate that. We'll square xi minus x bar, we'll square y minus y bar, and then what we'll do is that we'll also calculate xi minus x bar multiplied by yi minus y bar, right? So after doing that, here we will actually get a particular value, right? And we'll need to sum up all of this value to actually get that. Why we are actually getting that? Because in the b cap formula we need that term in the numerator, and from the summation of all the xi minus x bars whole square we'll actually get that here, and that will be in the denominator. And we from this yi minus y bar whole square thing here, this yi minus y bar whole square thing, whatever thing we will actually get here, will actually put also using that thing in the correlation coefficient formula. Also, calculating these terms, right, a cap, so b cap is actually calculated in that fashion, but the a cap is actually calculated in this way, that is y bar minus b cap x bar, right? So basically y bar we already know that is actually our mean of y, and subtract b cap, right, b cap and then x bar, right? So basically b cap is actually calculated by the above formula, right, which we actually studied, and then x bar is actually just mean. So we actually just use the values, plug in the values 5.733, and we actually got the b cap somehow 0.967, and that's actually being multiplied by 31.6, and we actually got minus 24.709, right? So the fitted regression model is, that is, y cap is equals to a cap plus b cap x. So b cap we already know, x it's actually a new point to be plotted over the graph, means what are the point you will get on the graph, you will actually get the corresponding y cap according to it. And you also get to know that y a cap through this particular equation. So this is your whole model, and you can actually plot this. So this is a regression problem for now. So yeah, um, now you might be actually also asked to predict the value of y when you are given a value of x, right? So what you will do is that you will plug in the value of x, that is 30, into this particular equation, right? That is, what is that equation? You will actually, you have the a cap and a cap plus b cap x, right? So a cap is nothing but minus 24.309, and b cap is 0 minus plus 0.967, and this is being multiplied by 30, and you will actually get this 4.301. So this is your point on the line when you are actually having a value of x to be 30. So this is your whole regression problem is, right? This is your regression problem is. And in the next problem we will actually consider ANOVA, right? So let me review what were the steps of regression, right? So first, linear regression you already know, y is equal to mx plus c. Here we have a plus bx, b is actually slope, c is actually your constant, right, or say intercept. And then you have this actually a model, that is error term is actually y minus a minus bx, right, because error comes there. Y is actual value, x is the actual value, and b are your parameters, and x error is actually the error encode, that is the difference between this and this. So your model actually comes out to be something like this. That is the differentiation. You are using, not using gradient descent, you are using differentiation thing, and that derivation leads you to actually find the particular b value with this particular case, that is summation over all of the training examples xi minus x bar into yi minus y bar by xi minus x bar's whole square, right? That's actually in the denominator. Correlation, if you are actually asked to find out, then it will come out to be b cap multiplied by x minus x bar whole square divided by summation over all of the training samples by a minus y bar whole square. So this is how you will actually get the correlation, right? Is if it's zero, no correlation, positive means positive correlation, negative means negative correlation, right? So this is your training the particular numerical example, that is watching TV and the weight gain or loss, right? You will actually get some values of the TV watch and the weight, and you will actually need to calculate all of these particular things, right? X bar is actually the mean of x, y bar is actually the mean of y. We'll actually get the xi minus x bar whole square, means for all of the values y minus y bar, y minus y bar whole square, then whatever the xi minus x bar multiplied by y minus y bar, and you will actually calculate all of the values. You will actually get the results. On calculating the b, you will actually just do whatever here is divided by xi minus x bar whole square, means this particular term. So you will actually get the value of b cap. A cap is actually y cap minus bx cap, b cap x. So y bar is actually a summation, say mean value of y, that is actually this one. B cap is actually, you have calculated 0.967, and then x bar is actually mean of x. So you will actually calculate a cap. After getting a and b, you got the model, that is a cap plus b cap x, and then that's actually y cap, and so you will actually get this value if you are actually asked to find a value for a particular value of x, let's say 30. So you will actually plot 30 into this, and then we'll actually calculate the particular y. Right, this is how linear regression will work. You can plot a particular line and linear regression is over. Thank you so much.